Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And oh god, today this is a very exciting mission because yes, as everyone is saying right now, I myself was waiting for this mission to be completed and finally come back here on Earth since a long time. And finally, OSIRIS Rex is making a comeback to the Earth, obviously. Where else will it go? Okay, how are you guys? And I am really very excited for this one. Hopefully we will get to know a lot about the asteroid, the solar system, and how the origin, basically the origin of the life, how it happened and all. So welcome to the stream, sir, everyone. Hi Jatin, hi Sai Datta, Daniel, Kushagra, Boston Harbor, and yes, Audit Amplified, Lewis Smith, welcome to the stream. Hey Eldona, welcome. So yes, we are back here, and hopefully this time NASA will make it. If you remember, first of all, this is NASA's first asteroid sample return mission, and NASA had a sample return mission like this previously also with the Genesis one, but that had a not so good ending. Basically they were able to collect, so the Genesis mission, if you don't remember, that was there to collect some solar particles and cosmos dust. It collected it, so that was not a problem, but during the descent phase, once it was supposed to land it back on the Earth, there was some sensor failure, and because of that the parachutes did not open, and it crashed onto the surface. But today hopefully that won't be a case, because obviously NASA is NASA, and like every other space agency, they will got some results out of it, and hopefully that won't be the case today. But if that happens, well, I'll tell you everything, what would be the scenario, and how they are planning to counter it. So just relax and sit with me, and you will get to know about everything. So let's just jump into it. So first of all, if you don't know guys, OSIRIS Rex was launched in 2016. The main target for this OSIRIS Rex mission was the Asteroid Bennu, and Asteroid Bennu was supposed to look like, what should I say, wait a second, just a second. Yeah, Asteroid Bennu was supposed to look like, a very grainy or sandy substance, but when they went in close, as you can see in this image also, there were huge amount of boulders and rock, and everything was not like they expected. So they literally had to do a software update on this OSIRIS Rex mission, in which they used another sensor. So basically the landing descent in was supposed to happen using only the lidar. Now they had to do a software update because they had to avoid these all boulders and all. They had to use the optical navigation camera also, which they did. So they did a software update, and the descent was supposed to happen with the help of the optical navcam as well as the lidar. So that happened. So here you can see this is the instruments and all which are there. We won't go into the scientific missions and instruments and all. Main thing is this one today, the TAG-SAM. This is the sample collector unit which is going to be returned today. This you are seeing is actually a thing which is going to be returned today. So yes, they collected the sample using the TAG-SAM and stored it inside this sample collector unit, and this sample collector unit is going to make a comeback to the Earth today. Okay, so how it happened, everything, we'll have a discussion about it. So if we'll let's have a look at, before that let's have a look at some key dates which has happened. So launch happened at around September 8 2016. Finally it arrived in 2018 in Asteroid Bennu, at Asteroid Bennu, and it studied the asteroid for nearly 2 years. Obviously they had to because they encountered such a boulder rich asteroid which they did not expected. So they had to study it properly, had to find a landing site which is not which does not have much boulders in it, and do a software update and all those things. So they used around 2 years to study it properly, map the surface, get those images collected, and properly know where can be the landing site. So finally it completes the its last flyover of Bennu. It collects the sample first of all on 2020. Yes, I streamed this one also, the collection of the sample. You can have a look at it if you want, if you're interested in more details on how the sample collection system works and all, but I will do that today also. So yeah, if you are interested, you can search for that stream also. Also April 7 2021 it completed its last flyover. It began its journey back to the Earth on 2021, and finally on 2023 September 24 it's making a comeback to the Earth. But guys, there is much more. Extended mission to the asteroid Apophis, which we will talk about, so don't worry about it. So this is how the spacecraft looks like, and if you have a look at it in a closer way, you will find that it is actually looking very similar to the Maven spacecraft of the NASA, which is a Mars orbiter. And yes, that is true because it has taken some components from the Maven mission. So spacecraft bus and all, some electronics and all. So that's why it looks like similar to that. And yes, so this is all about the launch sequence and all. Yes, so finally when it encountered the asteroid, what it did, we can have a look at it. So I do have a picture for you, video for you, you to understand how the collection looked like. So here you can see this is how it all went. It was going in very slowly, and then finally at a certain point above the surface, it went almost more slowly. Because of that only you can see the increase in frame rate, and pushed it down on the asteroid surface. Once it pushed down on the asteroid surface, there was a collection system mechanism which was turned on, collected the samples, and then finally it came back. So the thing is that although it looks a very rocky, bouldery surface, but their initial assumption of it being a grainy surface was kind of correct, because this was not exactly a very a dense surface, and because of that they were able to get more sample collected on their sample collector, because it was not as hard as they expected. So they were supposed to be landed onto the surface, and what they were expecting a 4 centimeter per second of hit back from the asteroid, but that did not happen. It almost around half a meter or so it went inside the asteroid, which was not supposed to happen, which they did not expect. And because of that only, you can see like there is so much of dust grains and all flying around. But since it went inside, it was able to collect much more sample, and also not only the surface sample, it also was able to collect the inside sample. So more science on the way, so that is really good. So after that, they were supposed to do what should I say, inspection of how much is the sample here. So this is the sample unit which they used to collect it. So talking about this sample, how it collects it, so there is this nitrogen gas which is used for sample collection, which I'll show you also. So this is how the sample collection looks like. If you'll see, this is the nitrogen gas which is pumped from the OSIRIS Rex. It goes inside up to the surface, creates some of, because it's a high pressure nitrogen gas, it creates some of the bold crater kind of a thing here. And because of that, since it gets reflected back to the here you can see, right, it reflected back and then the gas goes out, but since the collection material is heavy, it settles onto this sample collection tube. So this is a very indigenous and genius way to collect the samples, and yes, they did with the help of this mechanism. So since they pushed it down inside, so the nitrogen gas was much more effective, and hence they expected around 60 grams for it to be collected, but as per the reports, they collected around 250 grams, triple of it, 4 times of it. So that is amazing, because more science, more sample, more science, and amazing results is always a good thing. So yes, Audit Amplifier, you are correct about that. So that is the thing. But now, since the surface was soft and they pushed it nearly, much more inside the surface, and also since the surface was not grainy but rocky, there was one more problem which they encountered. So here you can see, this is, so after they have collected the sample, they moved back from the asteroid, and they had to take some pictures from the sample collection unit. Here you can see in that, and they were supposed to weigh this sample with the help of a very indigenous way, which I'll tell you also. So if you'll see, there is this the sample is much ahead of the spacecraft. So they were supposed to weigh this sample by using a very a basic physics phenomena, which is known as moment of inertia, which we all studied in our high school standard. So what they were supposed to do is, they were supposed to hang it all the way to the side, and then they were supposed to rotate the spacecraft. With the help of that, they were supposed to measure the change in the moment of inertia. And since the moment of inertia formula is around is like mr square, which means the mass and the radius. They all know the radius, but they can calculate the moment of inertia using the sensors, and then they can calculate using that formula how much is the mass they actually got. So they were supposed to do this, but as I said, you can see in this picture, right, when they inspected the sample, there was a sample actually flying all around the sample collector unit, which means that the sample collector unit did not close properly. Okay, and because of that, more they moved, the more of that sample was moving inside the sample collector unit, and there was a chance for it to go out of the sample collector unit. So they finally decided to cut off all that plan to measure, because of only using this picture only, they were able to see that yes, there is enough sample in it. So they rejected the plan to weigh using that moment of inertia, because that would cause more of that sample to go out. Instead, what they did was they did this. They slowly and steadily moved that sample collector unit, and then they stored that unit inside this heat shield and the return capsule basically. So once it is stored, finally now it is making a comeback. So this is all what has happened till now. Hopefully you had now a good understanding of what was there. So now let's have a look at some other things also. So it has been like 7 years which has commenced. So 24 September 2023, finally it will be landing at Utah. So let's have a look at the return profile now, how it will land on the surface of the earth, how will it make a comeback to the earth. Okay, so this is how it will look like. So in July 26, they made a maneuver to direct it to the towards the earth. On September 10 also they made a maneuver, and finally again directed it back to the earth. Finally on this capsule release happened on September 24, today only. September 17 also one more maneuver happened, and September 24, today only, 4 hours back, they released this capsule release happened. So go no go poll was supposed to happen. So yeah, it was successful, and then they released it. The spacecraft has diverted already to the a safer destination, because if it won't divert, it will go inside the Earth's atmosphere, and that won't be a good thing for everyone. So we want the capsule to go, but not the spacecraft. So it did a diversion maneuver over here, and then it will continue its journey to this new mission which it has been assigned, which we will talk about. But yeah, this is what it is. And finally it will make a capsule re-entry at 8:42, and then things will happen. So this is how the return trajectory before the atmospheric entry looked like. Now how it will look like once it enters the atmosphere. So at T minus 4 minutes 13 seconds, 4 hours 13 minutes, release has happened. So T minus 13 minutes, the initial atmospheric re-entry point will happen. It will be moving at around 27,000 miles per hour, because it will be moving at an escape velocity only. So there's that. And also it will have a you can see after at T minus 12 minutes 10 minutes 12 minutes and 10 seconds, it will reach a peak temperature of around 5,000 degree Fahrenheit, which is too hot to handle. But because we have a heat shield, so that is not a concern. Now finally at T minus 10 minutes 50 seconds, the drogue chutes will deploy at around 102,000 feet above the Earth's surface. These drogue chutes have a job of slowing down, as well as making sure it is pointing to the right direction, and it's not doing its what should I say, it's a high speed stabilizer as well as slow down, which that's what the drogue chutes do. So that's what they will do. And then at T minus 5 minutes, the main parachutes will deploy and slow the spacecraft the capsule down. And T minus 0 minutes, finally it will land in the Utah desert. And there will be the recovery activities which will happen. So this is the expected landing area. You can see this is the restricted airspace. If you live nearby, it's going to happen near the Salt Lake City. This is the expected landing area, and this is the restricted airspace where no aircraft is supposed to fly, because they will be tracking, military and all will be there. They will be tracking the descent of the capsule using the radar and all. So there's that. And after that, finally the recovery activities will happen. So this shot which you are seeing is actually a shot from the rehearsal which they did. So they dropped a capsule from the helicopter, and finally they did some the recovery activities. But here you can see they have some flags putting down on the surface. So these flags have a importance to it. Recovery team will put down the flags over here, and then the science collection team will come and they will literally scrape some of the sample from the flags from wherever the flags are. The scientists will decide from where they want to scrape, and they will scrape some of the material outside of the Utah desert and they'll take it home. But you might be wondering, why are they doing this? The asteroid sample is the main thing, right? Why do they want to take a sample of the desert? Well, it makes sense actually, because what they are trying to do is they'll try to study the desert composition, and they will make sure that whatever the composition that desert has, we don't have that on the asteroid sample return capsule. So there might be contamination and all because of the dust flying around and everything. So to rule out that possibility that this sample, whatever they are studying, is not from the Utah desert itself, they are taking a sample of the landing site. So this is, yes, some smart people out there which figured out, yes, they'll do something like this. So yeah, there's that. And then finally, this is how it will look like, guys. I will play a video which will summarize all the things which is going to happen and how basically the OSIRIS Rex mission itself. So have a look at it, and then we'll talk about the future of the OSIRIS Rex.
September 2016, on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS Rex spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS Rex stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS Rex is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS Rex will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
So hopefully that clears it up. The next this thing also, right? The future of this mission. So yes, I think I should summarize it. So that was a pretty self-explanatory video, and I did a proper explanation, detailed explanation of all the things which it had done. Talking about the future, yes, it will go to the Apophis asteroid, which is a near Earth asteroid only, and that asteroid is we have interest in studying that asteroid because it will come to the Earth. There is some probability for it to come very near to the Earth. Okay, so if we have a certain spacecraft which is going to study it, it would be better for us to understand its trajectory, its orbit, and whether, if at all, we want to, do certain things about it, whether we can do it with the help of this spacecraft only, because you never know, her life could end because saving the earth itself, because that's what we have proved using the NASA's DART mission, right? If we are going at a certain speed with the relative to the asteroid, we can change its trajectory. So if this spacecraft is already over there, and we get to know, yes, it's going to hit the earth, then yes, this spacecraft can save us one day. That is very beautiful to think about, right? Ending her life and saving all of humanity. Just wow. Okay. So yes, this is pretty much about it. Let me now wait a second. Let me just move on to the other part. I think we have the
That command came after more than almost 4 billion miles of spaceflight.
We have the stream, guys. So I'll move on to that.
About this asteroid Bennu. The SRC has now been separated from the main OSIRIS Rex spacecraft and is coming in rain or shine today. So team members are keenly aware of the weather conditions out on the range. It's looking pretty great for today. We did have a bit of rain the other day, which softened up that landing spot just enough to make the SRC land perfectly smooth on that surface. The temperatures are going to be around the 50s, 50 degree Fahrenheit. Low winds out there, calm winds at the surface around 6 miles an hour, pretty light. Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Just a few moments ago, we heard the helicopters take off from here to head out to Wig, just at the edge of the landing ellipse. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. But for now, back to you, Lauren and Jim.
All right, thanks, James. We'll be back to you for mission status updates throughout the morning. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. In less than an hour, the sample will touch down in our landing ellipse at the Utah Test and Training Range, managed by the Air Force, about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us, where the sample will end its journey today. Tomorrow morning, a C-17 aircraft will take off from the runway behind us and deliver the sample to NASA's Johnson Space Center in Houston.
Unbelievable. Can't wait.
Oh my gosh, I can't wait to see that C-17. Oh, that's
okay, guys. So yes, this is how it is. We are T-minus 49 minutes from the touchdown. Things are looking good right now, and hopefully we will see a proper, sample return today, not like Genesis.
Solar system back to Earth for detailed analysis. Mission planners selected a small asteroid called Bennu as their destination. Following a successful touch-and-go procedure to grab a sample on October 20th, 2020, OSIRIS Rex has been making its way back to Earth. It's been a thrilling ride, already packed with technical achievements and scientific discoveries. Today's historic landing continues that saga, promising exciting research ahead. Beside our main event this morning, we've got a ton of extremely cool stuff. We'll hear from a special guest astrophysicist whom you probably recognize more for his chart toppers. We'll speak with one of the helicopter pilots about his role in getting recovery teams out to the landing site and bringing the capsule back home. And we'll even hear from the cast of the film Asteroid City. And of course, we'll give you a front row seat to the mission itself, the science, the engineering, and why a mission to gather space rocks. Well, rocks.
The way they are, broadcasting. So that is nice.
Let's now take you to Wig Mountain, where our field reporter, Sophia Roberts, is standing at the forward edge of the vast landing zone, where she joins us live now. Sophia,
thank you.
So guys, if you have any questions or so, you can definitely ask and I'll try to answer it. But things are looking great. But this is not a good footage quality-wise.
The atmosphere at approximately 8:40. It will descend through our atmosphere for 13 minutes before touchdown. Once it does touch down, our team with the recovery team will go to the sample or the capsule and start that carefully rehearsed recovery process. Now, I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive. Back to you, Lauren.
Wow, Sophia, I think she has the best seat in the
Oh my
house.
God, take me there.
I want to go there. All right, let's get some quick facts about the OSIRIS Rex spacecraft. Filled with fuel, the vehicle weighs more than 4,600 pounds. That's about the same size as 3 large cows. Did you know that, Jim?
I did not, and I'm afraid of those cows.
Let's stay away from the cows. With its solar arrays extended, the spacecraft is about 40 feet long, or the size of a short school bus. The solar
Yes, they do have that, they do have that probe kind of a thing, which they can use for Apophis asteroid, but they won't be having the sample collector when they this OSIRIS Rex is directed to another mission, which is the OSIRIS-APEX.
currently on its way to our landing zone in the Utah desert. So, Jim, I think importantly, the team can't just open up the capsule right on the desert floor, right? What happens next?
So next we have to safe it, we have to bag it, we have to contain it, and transport it to the clean room about a mile from here. And in that clean room, we will actually bring the sample return capsule in, take off the back shell and the heat shield, and carefully arrange to nitrogen purge that special sample container inside, so it does not introduce any contamination from Earth, because we want asteroid, not Earth.
That's right. And I love missions like this because I find my own imagination just bursting with possibilities and questions. And so with about a little bit more than 30 minutes to go before the SRC hits the top of the atmosphere, we're going to take a few minutes to dive into the nuts and bolts of the mission itself. We've got a great mission overview to help explain. Take a look.
In a recent interview, Sir said their future initial plan to return moon sample. Do you have any information about it? Deepan, I have as much information as you have. So it is planned. So basically the thing is Chandrayaan 4 or the LUPEX mission will happen first. After that, hopefully when that is successful and if there is certain interest in discovering the lunar south pole at that time too, then there will be a sample return mission, hopefully. So recent interview also in by Somnath sir, he also discussed about the sample return mission. So they do have that in plan, but right now everything is just what should I say, in they are just things are just in this planning phase. Idea is there right now. Nothing has been directed into the planning phase basically.
The spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS Rex will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Yep, we already have discussed all about this, so you must be having a good understanding of all this.
Wow, I get chills every time I see that.
So T minus 42 minutes left. at around 30 minutes still left for the capsule to hit the atmosphere.
OSIRIS Rex. It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning, we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule underscore B asks,
So,
what's the significance of
Let me answer you this question also, that basically this, in short, this asteroid is untouched. That's it.
Never get here, so we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have?
Okay,
All
he
right.
did not answer much. So basically, this asteroid is a carbon-based asteroid, and it has formed during the initial stages of the solar system formation. Until then, it has been untouched. So by studying the asteroid, we will be able to know the origins of the solar system and all.
We can see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning.
Okay, so one more thing is there. When the recovery will happen, so there is a very strict protocol which they need to follow. But let's listen to them first.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar or on-scene commander of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is under chute, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule, and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test.
Okay,
we're going to keep
so
them safe from that.
I was telling about the protocols which they need to follow. So they have a very strict protocol policy which they need to follow. So first of all, since it is coming in from space, they don't want any bacteria, virus which is space related. And if you have seen the expanse, there was something called the protomolecule which caused a havoc on entire solar system. So they need to make sure the sample is not sterilized but isolated, and making sure that whatever they study from it, it remains over in a certain isolation, so that they can properly study and make sure that we don't have any contamination or virus or an bacteria coming in. So this is why they have a clean room and all those protocols which they need to follow before they can actually study the asteroid.
But I'm guessing you know him probably more, probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS Rex. I can't be with you today. I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission, especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Lori.
Great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori.
Thank you.
It is a really exciting day. So OSIRIS Rex is part of a larger autumn for asteroids, asteroid autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. Right on the heels of the sample return happening today, in 2 days, on September 26th, is the 1-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test.
That
demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
so many asteroids, right? And yes, I also streamed about the Lucy mission, so you can have a look at that also if you are interested. That is also a very cool mission, to be honest. A very cute and cool mission.
There.
So actually, OSIRIS Rex gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space, and that actually kind of acts as a force that kind of pushes back against the forward trajectory, and so it changes our predictions on where the asteroid might be. Over time, it really makes a difference, and OSIRIS Rex gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable.
That is the reason why they want to go to that Apophis also, because this is a very thermal pressure which you might have heard. So since in space nothing is there to stop, right? So when it has absorbed all those radiations from the sun, when it moves to the other side, it try to expel all that radiation, and because of that there is a thermal pressure which is created, and finally it kind of acts like a thruster. It's a very small thruster, but it's enough to change its trajectory a lot. So a lot at a further distances. So if let's say the Apophis is going to hit the Earth, we need to understand its final trajectory first of all. So to do that, we need to understand the proper the structure of this and how the thermal pressure is behaving, so that we can accurately predict its the orbit of it.
Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS Rex spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitored.
Talking about that spin, I want to talk about that spin also. So it is a good way to talk about it. So if you remember in the rocket launches also, especially in the sounding rocket launches, we have the spin which is given to the rocket to enhance its stability. So that is what we know as spin stabilized craft. So it's like, a top only. So when a top is just resting, it's you know how it is resting, right? It's kind of resting on its side. So, but when it spins, it is actually standing on that needle. So,
Thanks, James. Very soon, NASA's Artemis.
so it's a similar reason only. So here also a spin is initialized so that it maintains its orientation and it is stabilized. So this is why we have that spin stabilization for this sample return capsule.
13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS Rex, the first U.S. mission to collect a sample from an asteroid, will return samples from Asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS Rex and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren.
Hey,
we are under
Dane
20
is here.
minutes away
Dawn
from
is here.
EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Ah, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
The moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia.
Is
wow,
it the
I can't wait.
furthest? I'm not sure about it. I need to read whether it is the furthest or the Hayabusa mission, because the Hayabusa mission from JAXA was the one which demonstrated this Hayabusa 2 basically demonstrated the sample return from an asteroid properly. So that has already been done. That also I streamed, so you can have a look at it. And now today we are going to have a OSIRIS Rex mission.
From this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies: the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is. And it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment, and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
it's the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the...
So okay, so we have a question whether we'll get which country will get the samples. Will it be India, which included? So I definitely know that the samples will be shared with JAXA, because JAXA has signed their contracts with the NASA to exchange the sample. Basically they will give the Hayabusa samples to them, and NASA will give this Asteroid Bennu samples to them. So it's like studying both the samples and contrasting the differences or the similarities in the composition and all. This is the main goal, and basically if we'll compare both of the samples and do the study simultaneously, they can actually retrieve much more science which is possible. So I do know that they will be sharing with JAXA. I'm not sure about the other countries. Till now, whatever information I have, I don't think so. There is a sample sharing which is supposed to happen with any other country, but JAXA definitely not sure about other countries as of now.
Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to the Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation.
Wow.
We have a science team led by the University of Arizona. And then we have
recovery operations.
Canada and Japan.
Helicopter 1 is
So all of
departed
them are really
with
critical to
to
us.
station
And
keep
I'll just stop
outside
you
the
right
landing
there.
ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science, an expert on how our planet works in climate, can you tell us how this asteroid mission and the samples we return might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice, being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right. Well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for all
Wonderful.
you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because
Recovery
of its
operations. Helicopter 2 has departed with to station keep outside the landing ellipse.
All right. So
Both the helicopters are out, and hopefully we'll see whether they'll be able to recover it.
Isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS Rex had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Yep. So the OSIRIS Rex actually orbited the Bennu to understand to make sure they have a proper map of the Bennu as well as to study the Bennu. So yes, it did orbit the asteroid. So that's why it has a Guinness World Record for that.
Head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of
They
ancient
had
solar
to they tried to recover it during the Genesis mission also. So that was in 2001, if I'm not wrong. But as I said, it crash landed, so they were unable to retrieve it properly. I think they were able to retrieve it, but it was not proper. It had contaminated, so was not proper for scientific observations.
SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. We grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today. Period of few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues in a special clean room perfectly designed for this mission will unpack those precious samples in the small sample canister, the small device that was used on the end of the TAGSAM, and they will go through a process to get it checked out, to do early reconnaissance, and to protect it very carefully.
That is incredible, and they built that whole clean room. No other asteroid samples before.
Right.
This is the first one.
First ever.
First ever. As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS Rex sample return, a journey of 7 years and nearly 4 billion miles.
15 minutes from the touchdown. So yes, it's happening, guys. Happening.
James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing crazy deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations. Helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound within. We have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles getting reduced to the scale of mere miles, 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here.
Where you can see, right? I think it is able to capture that SRC, which is nothing but the sample return capsule. And hopefully we will see how the things would work. Right now things are looking great, and we are T-minus 30 minutes from the touchdown. And yes, let's hope everything goes well.
Or shine.
EO milestone. The SRC has entered the Earth's atmosphere.
There you go.
UTTR tracking assets have acquired.
And guys,
and here we go.
Whosoever is living in the western coast of US, Hopefully, I'm not sure, but I think you should be able to see the fiery glow. So this is from the infrared tracking camera, but you can actually catch a glimpse of the fiery streak. If you do, please do share it on the Twitter at RocketGyan, and we'll have a look at it.
Experience right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky.
Wow, look at that. That is so cool.
We're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC.
Hey,
a
there you
phenomenal
go.
view of
That fiery
SRC
streak
coming in across the sky.
Fiery streak is happening, guys. It is in the upper atmosphere, and because of that, the plasma is created. Things are looking good.
Going to be approaching the Utah test and training range just a little bit further to the east.
Team
entry was
minus
EDO milestone. SRC is experiencing maximum heating and
There you
maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC.
Both are happening at the same time. How cool is that?
Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere.
What was that?
You can see our high altitude plane searching for that SRC. You can see it faintly on your screen there.
Okay.
Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah test and training range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet.
So it is above 102,000 feet right now. Everything is looking good.
Mountain time, the OSIRIS-APEX spacecraft is at its closest approach to Earth. That will be on to its extended mission
open up.
the asteroid Apophis in the year 2029, continuing
Previously also
at another world.
We had an issue with drogue chutes, and
in just a few moments we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck.
Can't see those numbers over here, so can't say whether drogue chutes.
You can still see the SRC on your screen very faintly in the distance. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere.
Don't be another Genesis, please.
And in just a few moments, we should be entering into special use airspace. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today.
Open up, open up. T-5.
We did, as I mentioned, have a couple
we should see a main chute deployment at T-5 minutes or so. T-5 minutes main chute should be deployed, but let's see. Drogue chutes I can't see at all.
Streaking in.
Okay.
This is from our high altitude cam.
But drogue chutes, if they are not deployed, I'm not sure how, because it has not been slowed down. It is not getting slowed down. Can we? Yes, I can see the tumbling also.
Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation.
Please, at least the main parachutes open up.
Continue to track with our high altitude camera here.
Oh God.
As I mentioned, that sample is thermally isolated within that SRC, a very complex labyrinth network of piping and tubing leading into that sample canister within that just a few years ago was on the other side of the solar system from us sampling at Asteroid Bennu. The team has incredible precision on this mission as well. Just a few days ago, on the 17th of September, they did their final trajectory correction maneuver, TCM-12.
Parachutes.
Our velocity by 3 millimeters per second.
Come on. Uh-oh. Okay. Oh, parachutes deployed.
Wow. And after an
Finally it happened.
Across Earth's atmosphere,
at least the main parachutes deployed.
See just a sigh of relief from the team. I can hear some applause here.
Oh.
There it is, that orange creamsicle colored parachute. Just a delight, a sweet delight to see.
Not sure what happened with the drogue
shoots. Test and training range. A phenomenal view. Just wonderful to see that deployment. That is at around 5,000 feet elevation above the Utah Test and Training Range, and now this is like a marathon
I was
runner
literally feeling
that last
whether this will be another Genesis or what. But main parachutes deployed, so it's now will be slowed down. Now I don't have any issues. It will be slowed down and it will hit the Earth at soothing 11 miles per hour.
Out at the edge of that ellipse, watching from Wig
Nobody heard the clapping at of the drogue shoots, right? Because I don't think so. Those got even deployed. So we also heard the relief in the mission control voices when the main parachute actually got deployed. Not sure, but yes, finally the main shoots deployed.
To the rugged terrain of the Utah Test and Training Range. Looks like winds are relatively low. Not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down. That parachute there.
But since the drogue shoots, now there will be another problem. Since the drogue shoots did not deploy and the main shoots directly deployed, if that is the case, not sure, but if that is the case, then there could be an uneven amount of G-forces, or you can say the maximum G-forces which the capsule might have experienced, and it might not have been designed for that, not sure, but there could be that problems. Otherwise, we don't have any problems with it, so I guess that is fine. But yes, the main shoots deployed.
Leading up to this key moment and are ready to begin those operations to get that SRC into our portable clean room here.
Tumbling is not a problem, so now it's getting controlled by the wind, so it's okay. So what should I say? The touchdown speed is at around 11 miles per hour, so it's the capsule is designed to hit at 11 miles per hour at any angle, so it's fine, so not a problem.
This could be a little bit faster, a little bit slower as we get closer in. This wind speed here is a variable that is quite hard to predict, especially once you're high up in the atmosphere. We did release a weather balloon earlier on this morning rather, to get a profile of our atmospheric conditions. The team puts those into various models as they prepare for this key moment. But once again, they are a little bit hard to predict, a little bit variability. So,
but we need to see whether the sample is even there right now or not, because I saw that one light blast kind of a thing which happened. Not sure whether what was there, but we'll have to wait and see whether it is intact. The capsule is intact or not.
EDL milestone. Helo 1 has visual on the SRC below the chute.
That is phenomenal. Let's see that view here from that first helicopter. They've got visual on the sample return capsule under parachute, that orange creamsicle colored parachute, really bright.
Yes, we can see that.
Morning light over the Utah Test and Training Range. A great view of the SRC we can have now from our helicopter as it continues to make its final descent to the terrain below. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour.
Thank you so much, Mars 2028, for that too. I totally missed it because I was so focused on that landing part. Can you tell us more about the heat shield? Sure, I'll tell you more about the heat shield.
Our descent, and then ultimately that main
Let's get this over with first, and we'll have a discussion over that.
You can see right in the center of that crosshair, that is the parachute with the SRC dangling beneath.
SRC is nothing but the sample return capsule. So we need to now wait and see.
The team on the
We can see the shadows.
The team on the WB-57 doing a great job.
Milestone, we have touchdown.
And touchdown confirmed.
SRC has touchdown.
Sure, the drogue chutes did not open. It did the touchdown 2 minutes 40 seconds earlier.
Time capsule to our ancient solar system.
Now we need to
Unofficial
see
touchdown time,
what was
8:52 a.m.
what was the actual. We can have certain deviations in the touchdown time with the the atmospheric conditions can change, but yes, it has touched down, so hopefully everything is fine. We just need to see now. First of all, the people will not go directly over the landing site because they will have to wait and see the helicopters and the planes will fly over the landing site and see whether everything is fine. No gases are leaking, no hazardous material is over there. Once that is confirmed, they will allow the recovery team to go over there and collect the sample.
Originally predicted. It was in a rush to get back here, carrying amazing.
Yes, when the drogue chutes won't open up, then it won't slow down. So this is what is going to happen. But kudos to NASA for the main chutes to actually handle those G forces at high speed, because they would have, the main chutes were not designed for that high speed to slow down. But it actually did not go that bad. It kept up its promise, and finally we had a touchdown. Still waiting for a proper view of the capsule, then only we can see whether what has happened over there.
Everyone has a role to play. It's going to be simultaneous action.
See, everyone is kind of happy and right now curious to see whether things went all right. Hopefully we'll get a visual of the capsule. So talking about the heat shield Mars 2028, that heat shield is similar to what we have for other missions also. There is no as such different heat shield which they have. The Apollo missions, the ISS, the SpaceX and the Soyuz and all those things. So whatever, even the Curiosity rover and Mars rover and all. So whoa. So that is the case. So heat shield is no different. Heat shield is like that only. But obviously the heat shield was a bit smaller than what we have for actual capsule. So yeah, that is the case.
Helicopters 3 and 4 are leaving rig for the landing ellipse.
You see some big smiles from the team there. They are getting those helicopters out to the landing ellipse now to begin those recovery operations. The first person to approach the SRC is Stu Wiley, our on-scene commander. You see the helicopter, the last of them, taking off from the Wig Mountain just at the edge of that landing ellipse. These helicopters will have a trip out to find that exact touchdown location of the SRC and begin those recovery operations. Stu Wiley, our on-scene commander, will be the first person to approach that SRC. He'll do an environmental safety sweep checking for unexploded ordnances. As he mentioned in his interview earlier with Sophia, he understands this range. He's worked here for a number of years. He will brief the team on any possible dangers that would be presented to them as they begin those recovery operations. And then a team member from Lockheed Martin will begin to take gas and thermal readings once the area is safe of that SRC to determine whether or not it is at safe operational levels for the rest of the team to begin the recovery operations. As I mentioned, this is going to be simultaneous action. The team has prepared. They're all going to be wearing these bright white UV shirts, sample recovery shirts. And you'll see them walking out to that sample in just a few moments here once those helicopters land.
We need
great
to
view
wait,
once again from our high altitude plane. You can see the parachute there.
Confirmation of whether
our SRC.
How the things would have gone, but yeah. Still waiting for the physical condition to be all right. Hopefully, see, 11 miles per hour, that is what... if the parachute was not damaged, final velocity must be 11 miles per hour only, no matter how fast it was going previously. So because eventually achieves a terminal velocity, and it has to move with that only. But the problem is, if the parachute, was the parachute all right? Was the sample return capsule all right or not? That is what we need to check right now.
As they get out there and check exactly how our conditions are for the SRC and the surrounding area. You heard Stu mentioning the team might need to wear some boots. The operations could get a little bit slippery as they begin to recover that sample.
So talking about the contingencies, so NASA already had prepared everything. So they had a planning for the crash landing also. So if anything would have, everything would have failed, what would be their plans for the crash landing? So they had all those things already in place. Obviously, the first thing would be to make sure the human lives are not affected. So
not billowing at all. It is almost perfectly flat, at least from this perspective, on that desert terrain.
Okay, nice. So why is he mentioning that parachute is flat? Because when the touchdown happens, the capsule is actually dragged over the surface, because it's like, you know, if you have done a skydiving or kind of you know, the parachute related stuff, you know, even after touchdown the parachute is actually active. It gives you that force and all. So that similar phenomena is followed over here also. So if the wind is high, then your sample return capsule can be dragged.
Located the parachute on the ground.
You just heard that confirmation from that high altitude plane locating that parachute on the ground. This location info will be relayed to our team members aboard those helicopters as they begin their approach out to the landing zone.
So the capsule has landed. Still, I'm not celebrating because I need to see the physical condition of that first, whether that is all right or not.
We do have confirmation from the high altitude plane, as you just heard. We're still working to get confirmation from our NASA helicopter. It is on its way out to that landing zone as we speak, so we should hopefully have that view up in just a few moments. You continue to see our team just next door, the mission operations team, all looking at that high altitude view. Right in the middle there, just pointing around with the UV white shirt, is Rich Witherspoon from Lockheed Martin. He has been leading a lot of these operations for the past couple months. He's been preparing the team for this exact moment and really has been a great leader, helping us get ready for these recovery operations. Yeah, so this ellipse here, this landing zone, is a quite large setup here, and this was chosen intentionally for this mission. It's about 37 miles by 9 miles total, this landing ellipse, out in the Utah Test and Training Range here in Dugway, Utah. This is an enormous facility, as you heard earlier. It's about the size of Rhode Island.
Now,
this whole facility.
We might have got the access, basically the recovery team might have got the access to the landing site by now, but since there was some anomaly during the seems like to be an anomaly during the landing phase, so they need to be sure about everything is fine, and they'll take their own sweet time to make sure everything is as per the plan and safe for the humans to go there and do their recovery part. Because if the things are not stable, the explosion can happen anytime. So that's why the military team is involved, to make sure the sweep is like that, to make sure it's stable and safe for humans to approach.
Looking at the parachute at rest on the
How
surface
long
of the
will
desert.
till the people will go near it? Not sure. They'll have to get a clearance from those helicopters which are surveying the area right now. Once they get the green tick, then only they can go. So they will take their time right now, because obviously there was something which was not as per the plan.
The recovery team, the recovery crews are responsible for securing the sample return capsule, the landing site around it, and helicoptering the SRC to a portable clean room that's located just next door here on the range. And just a little bit later on, it's going to be attached to a 100-foot long line beneath one of the helicopters, and then will actually be flown to the clean room. This was determined to be the best possible way to transport that SRC safely and efficiently, to get it on a nitrogen purge and maintain that pristine nature of the sample within. As I mentioned, this is an enormous ellipse, 37 by 9 miles. It's a large expanse to cover by car. It's a very bumpy ride out there as you kind of start to make your approach across this rugged terrain. With the helicopters, it will be approximately a 20-minute flight back with that SRC. They take it at a nice slow pace, effectively parading the SRC around, just giving it its last big moment as it is served its purpose officially at this point of getting that sample canister.
Not sure
safely
what
here to Earth.
those tracks are though. We can see those tracks, right? Whether those are tracks of some certain car or vehicle, not sure. But we have to wait.
These are places of interest for the sample curation team that will actually open up the sample canister in the coming days down at the Johnson Space Center in Houston, Texas. They have a phenomenal sample curation facility there, and these samples from Asteroid Bennu will join a historic collection of other asteroid materials, including samples from the Apollo mission, samples from both the Stardust and Genesis missions, as well as Antarctic meteorites that were collected by our scientists. In the coming days, we'll actually know exactly how much sample we got back from Bennu. The original mission requirement was 60 grams of pristine sample from the asteroid surface. Based on some very clever engineering, the team believes that they have potentially 250 grams, or 6 times that mission requirement, inside. And so we just heard that unofficial touchdown time was at 8:52 a.m. Mountain Time here at the Utah Test and Training Range in Dugway, Utah. If you're just joining us, you see that view right now from one of our high-altitude planes observing our touchdown location. On your screen, just
hopefully we will get some views from the helicopter also, because that are actually much more nearer to the capsule. We can actually see the capsule over here, but not sure. We can't have, this is not a high resolution one, so we don't have a proper, what should I say, a visual of what is the physical condition of the capsule.
Fairly large parachute that helped us decelerate on our last leg of the journey.
So as I told earlier also, let me repeat. So if the conditions are fine and the rescue team is able to get over there.
Actually, that the main parachute deployed much higher than was originally anticipated.
Obviously.
It was originally supposed to deploy at about 5,000 feet elevation, but it actually deployed at around 20,000 feet, so much higher up. So that would explain our kind of earlier touchdown time than expected here.
It does not explain actually. If it was deployed much higher up in the altitude, that means it was slowed down at a higher altitude. But yes, we know why it was deployed at a higher altitude, because the drogue chutes, I think, was not able to deploy properly. So the main chutes had to take over. You know, the Big Daddy had to take over. So hence the deployment happened at that time.
As I mentioned, there are 4 recovery helicopters in total. The mission operations team is continuing to monitor the situation.
Yes, March 2028. That is also because initially they had this 60 grams was planned, right? I'm not sure how much they have right now, because they did not even weigh this time, because they that was, as I told you earlier also, the sample collector box was not closed properly because of the boulders and all, and the sample was leaking, so they was unable to weigh properly how much is the sample. But hopefully that extra weight did not cause a problem for them.
One of the first goals once the team gets out there is to safe and stow the parachute and begin to mark places of interest, as I mentioned, for that curation team to begin sampling. This is all a very well coordinated machine, very well oiled machine that operates in tandem. They've rehearsed extensively for this moment. So we just heard from the team in that mission operations room that they have visual of the parachute, that orange parachute that you saw on your screen moments ago. But we do not yet have visual confirmation of the SRC itself. The team is continuing to survey the region.
That is not good. Oh God. Oh God. What was the parachute then? No. So they don't have a visual confirmation of this capsule yet. They do have a visual confirmation of the parachute. That is not good at all.
Recovery operations. Kilos 1 and 2 are in the area of the landing site and are in a search operation.
So you just heard that call out from Tim Preiser, who you see on your screen there from the mission operations room. He just announced that Helos 1 and 2 are now at that landing site. They're pointing out something on the screen. I see some smiles. It seems like we might have potentially some more information on that SRC in the coming moments.
Not looking good.
Helos 1 and 2 will be surveying this region, looking for both that SRC and also eyeing up the region, looking at that
that could happen.
All of the ground-supported vehicles have left rig and are in pursuit of the landing zone.
So some more team members are going to be heading out to that landing zone as well in support of those 4 helicopters that will be the main group recovering that sample. The main helicopter will be actually attaching that sample return capsule once the team has it located and ready to prepare for recovery operations. They'll load that on.
Yes, Alfonso, you are right about it. This can also happen, that the chute is covering the space capsule. Obviously, there was something which was dangling near the parachute, under the parachute. So need to see what was it and if the parachute is covering the capsule.
Location would be. We do have visual confirmation of that parachute, as I mentioned. Rich Witherspoon radioing out to the team. And now we have a view from our helicopter of the landing location. You can see the sample return capsule dead center on your screen, that kind of dark gray black object right there. And then just to the right of it, a little bit below, is our parachute. It appears to be resting on the surface. We're getting a zoom in now from our NASA helicopter. And you can see now the SRC. At last, we have a visual of it.
Finally,
on the
we have a
surface of the
visual.
Utah Test and Training Range.
But
That is a pleasant sight for the team to see.
Recovery operations. Helo 2 has visual on the SRC. I repeat, SRC has been located.
And we have visual on that SRC.
So
it appears that the
finally,
parachute has also disconnected. It's a little bit off from that SRC, disconnecting from the back shell. The SRC appears to be resting on its nose, that heat shield that protected it the whole way down through that entry, descent, and landing. Lockheed is celebrating that moment. I'm sure they are breathing another sigh of relief here. It's been a wild morning for everyone involved. They've been up since the crack of dawn, just a little bit further north from us in Waterton, Colorado. They gave the go command to actually release that SRC that you see on your screen. Right?
I mean, we have a visual confirmation, but this position for it to rest like a total, straight like this, it's very weird, to be honest. Do we even have a not sure. It's fully black right now, so we can't say about it, but it should have been tilted, right? But it's not tilted. There we have a nice close-up view, so everything looks to be good enough, I guess. Things are looking good only, but hopefully yeah, it looks good though. Hopefully that is the case. We don't have any problem with the capsule and all.
Very panoramic terrain at the Utah Test and Training Range. It's a great location for us to land this sample. The team looking a lot more relieved now that we actually have visual. And we should be able to begin those recovery operations shortly. Inside that sample return capsule are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days.
Actually, the capsule is actually, the parachute has been cut off kind of like that only, a bit earlier, or not earlier, a bit behind than the capsule itself. The parachute is not this long. That's what they said also. So the parachute, once it got landed or what, the parachute was detached and then it flew away a bit. But again, it's very either it's a very soft landing over there that it's able to it's able to rest over that nose cone, because it should be a bit tilted. Not sure whether the nose cone itself survived or what, but we have to wait and see.
Samples from an asteroid to Earth, and these samples will be analyzed for decades to come in laboratories around the world. And there is landing of our first helicopter at the site. Appears to have a nice soft landing. We're just probably a couple hundred feet.
Recovery operations. Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away, landing away from that sample. So a little bit of a hike for our team members to get out to that sample return capsule and begin our environmental safety sweep. As I mentioned, our on-scene commander, Stu Wiley, will be the first person of the team to actually approach the sample.
Looks intact.
Check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range. And then also make sure that that SRC
you can see, right, the parachute is not attached with this this thing. So also, if the drogue chutes did not deploy, there was additional weight of the drogue chutes itself. So, or maybe the mechanism was like that, the drogue chutes was in the upper section and the main chutes was in the below section. So even if the drogue chutes did not deploy, then also the upper shell will go off for the main chute to deploy. Not sure what was the architecture behind this, but we have to wait and see how the things were there. But right now what will happen is the recovery team will come near to the capsule, analyze whether everything is fine, and they will place the flags around it. Those flags will be useful for the scientific team to come and then get the samples of the desert area itself, because they'll need to analyze the samples from the landing location also, not because they want to analyze how the landing went, but because they want to know what is the composition of the desert area which is near the landing site, so that the contamination of those particles on the sample can be ruled out.
The team members will extract the back shell and remove the heat shield from the SRC. It served its purpose. We're mainly now concerned with getting the contents within that sample canister containing pieces of the asteroid regolith out of that SRC. We won't actually, as I mentioned, be opening that sample canister just yet here at Dugway. The team is simply focused on getting that SRC, or the sample canister rather, on a nitrogen purge. And this is to maintain that pristine nature and prevent any kind of contaminants from the atmosphere from getting into our sample within.
Recovery operations. Helos 3 and 4 have been cleared to land at the recovery site.
And the rest of the team is closely behind, ready to land at the recovery site to begin operations. This will be simultaneous action that you'll see here once we have the clearance from Stu Wiley to begin our recovery operations.
So Neeraj says, why are there tire marks? That is what I am also wondering. Maybe that
or any kind of roll marks, but the team, once they approach, will mark any possible areas of interest where the SRC possibly came in contact with the rough desert terrain. All of these regions will be sampled by a recovery team and will be passed off to the sample curation team at the Johnson Space Center.
That's what.
As they begin to unload and actually open up the sample canister there.
So those marks could be, a previous car which might have come here and done something. Maybe, we don't know. Mr. Heisenberg himself came here. Walter, right? If you have watched Breaking Bad.
SRC. As I mentioned, team member safety is paramount during these operations. There are possible potential areas of concern as the team begin these operations, including the temperature of that SRC. You see it looks quite charred there. It could still be a little bit warm. As I mentioned, it heated up to over 5,000 degrees Fahrenheit. So as the cool desert air begins to cool down that SRC, we want to make sure that it is cool enough for our team to actually begin those recovery operations. We'll also be checking the gas levels of that SRC to make sure that it is not outgassing from the batteries within, heating up during that reentry. We'll also be making sure that there is no live voltage present. And we see a view now from our high altitude plane that has visual of those helicopters landed nearby, just at the northern part of your screen. You can see one of them on screen now. The top of your screen there, it is centered up. There is our helicopter, and it appears that we have our on-scene commander potentially walking over. This is once again our high altitude WB-57 shot of our helicopters landed at the LZ, our landing zone. You can see some movement on the screen. It appears some team members might be approaching our SRC at this point to begin those recovery operations, the initial safety sweep. We'll just be observing from this high altitude for the next coming minutes, as the team actually will be setting up a camera on the ground for us to observe.
So if you have played KSP, you know, guys, that
and a note from one of the team members about the SRC itself. So they have approximately 40 hours. That is the amount of time it would take for any air to get into the sample. As I mentioned before, that sample return capsule is a complex network of piping and tubing inside of it, sort of like a labyrinth-like design, and that is intentional to make it incredibly difficult for any possible contaminants from the atmosphere to get into our sample canister. It's also sort of like a nesting doll, if you will, where it has multiple layers of protection that keep that sample safe within. All of that protective layering, once we get that sample into the clean room, will be shed, and we'll be able to actually access that sample canister within.
So yeah, I was telling about, like, so the main chutes were supposed to be deployed at around 1500 meters, but it got deployed at 6000 meters. So if you have played KSP, you know that there is a red, yellow and green marker on the parachutes for it to be deployed safely. So if you will deploy your parachutes when the parachute sign is green, red, that means it won't be able to what should I say, survive the aerodynamic effects, because the parachute will be torn off and all those things so will happen, and it won't be good. So the main chute deploying at 6000 meters rather than 1500 meters itself is a great achievement. And then if the chutes actually held up and there was no hole or tearing up of the parachute material, then hopefully it should be fine.
Recovery team is in the vicinity, beginning their initial assessments.
So you just heard confirmation from Tim Preiser that the team is beginning to actually approach the SRC for that initial environmental and safety sweep. You'll soon see our on-scene commander, Oscar Stu Wiley, approaching that sample return capsule. As I mentioned before, he'll be checking for any possible unexploded ordnances. You can see our mission operations team. They have been overseeing all of this morning's events, and they're going to continue. There we go on screen. You can see front and center there, Stu
and now
Wiley,
the
our
scale
on-scene
is
commander, and right behind him is Victoria team. They are both wearing personal protective equipment, gas
the
mask.
model was fine, I guess. Yes, they'll be, yes, they'll wear those masks and all.
You can see him scanning the region. He's checking for any possible unexploded ordnances, UXOs.
Recovery operations. Oscar is performing the unexploded ordnance survey.
Will they touch it?
And you just heard that he is in fact doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey, OSIRIS Rex Spacecraft. Finally delivering the sample, he is motioning over to Victoria team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed.
Wow,
a little bit closer.
This is also very interesting how the recovery operations
all over
go.
here. The team will collect samples. He'll begin to place flags. You can see in his backpack he's got a couple flags waving in the breeze. Those will be placed at areas of interest for our team members to sample once they arrive and begin those recovery operations. Victoria is now appearing to take out her thermal and gas reading devices. She's taking an initial thermal reading of that SRC as we speak, looking for it to be at an operational temperature of around 100 degrees Fahrenheit.
Operations. Lockheed Martin Safety is performing hazardous environment assessments.
And you just heard that confirmation. So she is performing that hazardous environment assessment, checking the thermal temperature of that SRC, as well as taking any kind of gas readings to make sure that we are at safe operational levels. She is also leading over. This is Victoria team from Lockheed Martin.
So exciting. It's so
Stu continues to sweep the
scary,
area,
to be
around her
honest,
for
because
the safe operation of
you
our
never know
recovery.
what is inside it, and if it attaches itself to you. I mean, obviously, we know that it is all secured inside, but still, when uneven things happen, like the drogue chutes did not deploy, then not sure what is the physical condition of the sample itself.
And insert a gas reading device within to actually take some temperatures. And you can see off to the left of your screen, Stu Wiley is actually safing and stowing away that parachute that helped take us the last leg of the journey. It's great news that disconnected from the SRC. That allowed our SRC to rest as it is now here on the surface of the Utah Test and Training Range.
Not the first Dipayan, because
Oscar is safing and storing the main parachute.
So Stu is going to get that parachute.
So it was not the first. We had the Hayabusa and Hayabusa 2 mission. Hayabusa 2 mission also recently, had the samples returns back to the Earth. That was also one of those U2, if I'm not wrong, U2 asteroid, which is also very similar to Bennu. So that is that. So hopefully things are looking good. I think she gave a good sign. Everything is fine. That's why she has taken off her mask. So that is a good news.
Discharging could cause potential presence of hydrogen sulfide from those batteries heating up, or carbon monoxide. And so that is why Victoria initially had her gas mask on. It appears she has now actually taken it off. So it appears that the gas readings indicate nominal conditions.
Recovery operations. Lockheed Martin Safety has confirmed no hazardous gas.
And you just heard that confirmation. So the safety assessment is successful. Victoria has confirmed that with her gas readings and thermal measurements of the SRC. They'll then go back over, Stu and Victoria, for a team huddle to prepare the rest of the team to begin the recovery
Cameraman
operations
is here,
and
guys.
actually get this SRC into our clean room here.
Looks like our cameraman is here. We'll get to see some good visuals from the capsule, hopefully.
Careful planning and preparation leading to this final phase of getting that sample back here to our clean rooms. I'm sure they've been holding their breath all morning, so they're getting closer to finally being able to take another breath and relax as we
just
actually
imagine
begin our
this
recovery
thing which
operations.
they are handling right now has come from the other end of the solar system. Literally, the vastness of the universe is amazing, right? That solar system vastness itself is amazing, but that is nothing compared to universe. So yeah.
This is where the parachute actually deployed at the top of the SRC
Now
capsule.
she will be
The sample return capsule, rather.
those flags will also be placed. We will see that also, but right now,
Live voltage.
yeah, she's
We'll
checking
wrap
for
Kapton
that.
tape around the two cut cable ends protruding from the back of the SRC where that parachute deployed. You can see her with that covering as we speak, placing it on the back shell.
She has touched that thing. Okay.
She has successfully placed that
Nice.
shielding on the back, that Teflon cover. Stu walking around behind, checking
Okay, that was two
the
only.
rest of the scene, walking back with the parachute that he now has safely stowed away. And you'll see Victoria
When
opening up
will
a couple
she-
gas valves on the SRC, taking those gas readings. Continue to do this throughout the whole process. She's also placing covers on those gas vents too to prevent any kind of contamination from atmospheric particles, particulates entering into that SRC.
Photos.
She's photographing the scene as well too. This is to keep careful note of exactly the procedures that she's going through for her team. So the recovery operations will be getting underway shortly now that the team has conducted their initial environmental and safety sweep. Everything appears to be nominal, which is fantastic. We do, in fact, have that SRC on the ground. The rest of the team will be approaching shortly. But for now, back to you, Lauren and Jim.
Her hat is on.
Wow. Thank you, James.
Oh,
Can you believe it?
OMG. Touchdown for science. What a great day.
For the folks at home, this is a huge deal, and they did it.
For the first time in history, we brought goodies back home from this kind of object in the history of humanity. So this is big.
This is so huge, and we're all doing it in cyber.
JAXA did it. I mean, first time for America, but JAXA did it before. So there's that. So I guess things are looking good only. Hopefully the physical condition is also all right. So if it is, I think it's time for us to celebrate.
So while the capsule was making its way through the mission
All event covers are in place.
All right, so we're making
good.
progress.
We're making
Very good.
progress.
All right, so while the capsule was making its way to the ground, mission teams in the Colorado control room and the mission ops area here in Utah were, of course, riveted by the live images. These teams have watched and
Great, guys. Finally, so OSIRIS Rex is on the ground and looks like everything is fine. So this thing is having the samples of an object which is on the other side of the solar system, which is itself is amazing to know. And after studying those asteroid samples in on the hands, it would be really amazing to see how the composition is, how it looks like, and how it feels like, to be honest.
The capsule is on the ground and in good hands now. Now, from here, from Whig Mountain, I am overlooking the vast landing zone, which, again, is larger than the state of Rhode Island. So, during that time, listening to James's commentary of the capsule coming through our atmosphere, we're all standing on the edge here, looking and scanning through the sky. But just to give you some context again of where I am, I'm about 4,000 feet up, overlooking a vast, ancient seabed.
Exactly.
So the mountains that are peppering along the edges over here, they are very muted colors. It's a beautiful pastel out there. And as we're looking over through the sky, it's hard to see because there's alkaline dust from this ancient seabed. And considering that the capsule has landed on the edge of the landing zone, even though I'm as close as I could possibly be, I didn't see anything over here. I will say I'm a little disappointed, but grateful that that capsule is in the most capable hands it can be, and that is the most important thing out here. So while I didn't see with my eyes myself, we saw it on the screen, and it's still a great day. So back to you, Lauren.
Wow, thank you, Sophia. And thankfully, we got that great image from the NASA helicopter. Wow. Just well done to that team. Thank you for that. So while we're keeping an eye on ongoing operations to prep for the SRC transport, we have a special message from someone who keeps a close eye on the entire manifest of the space agency's travels around the solar system.
Hey, everybody. Congratulations to the OSIRIS Rex team. You did it. You designed it.
There you
built
go.
it. And you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. It's going to help scientists investigate planet formation. It's going to improve our understanding of asteroids that could possibly impact the Earth, and it'll deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that inspire us, things that unite us.
Recovery operations, we can confirm that the SRC is not breached.
Beyond our reach. And the mission continues.
That is great.
Incredible science and analysis going to come.
SRC was not breached.
But I want to thank you all for everybody that made this OSIRIS Rex mission possible. It wasn't mission impossible. It was the impossible became possible. Thank you all.
And just as a reminder, we are keeping those operational milestones going, so you will continue to hear that throughout the broadcast. Thankfully, the SRC was not breached. Fantastic news.
That is great.
All right, as anyone who pays just even a little attention...
If it was not breached, that means the physical condition is also fine. That means, guys, everything is looking great, and we have a proper sample on the Earth. The asteroid sample on the Earth. How cool is that? Although Japan has also done it, but I'm not sure because if I remember correctly, that was not this large of a sample. I guess it was only some few grams only, but this is one large sample over here, so that is great.
Thank you for joining us.
Yes, it's everything feels to be okay, and we have Sunita Williams over here, right? So all those Indian people, we have Sunita Williams over here.
Believe could happen. It's amazing. Yeah.
And also, I mean, we both landed under capsule, under parachutes. There's not much better feeling when that parachute opens, I'm telling you. And it was maybe not equal,
obvious.
Pretty close to exciting and intense, and that parachute opened. Oh, it was thrilling, absolutely thrilling.
Yep.
Yeah, it's fantastic.
Well, that is fantastic. One of the things that I think will be really interesting is this, of course, this site is being considered as one of the candidates for the Boeing Starliner crew flight.
Right, and that's actually why we're here. It just worked out in our timing for our training and as we're working on Starliner, that we could come and actually view one of our prime landing sites, which is here at Dugway. And so that's actually what brought us to the area, so we could be here and sharing the experience with you today.
And we see this has gone so well, we are ready to land.
Recovery operations.
That's the place that our flight
The recovery team is performing their safety
This is a
huddle.
beautiful place. It's a beautiful day this morning. You know, no wind. I think the capsule just came right down under the chute, and hopefully we'll have a nice soft ride just like this
hope
capsule
so.
too.
Absolutely. And we just got a call out that the recovery team is performing their safety operations. Everything nominal.
So
good.
you guys will be coming back, and maybe someday with samples yourself, brought back by humans.
Indeed.
What do you think about that?
Again, we're in that era of going beyond low Earth orbit now with humans, you know, headed back to Moon and potentially one day to Mars with the Artemis program. And it is a thrilling time, as you mentioned earlier. So much taking place within the solar system, the near solar system now, and it's fascinating. Great time to be in human space.
Awesome.
I think I'd be a little bit nervous to go to an asteroid, so,
Wise
so
woman.
I'm
She's
super
wise.
glad the spacecraft did it, and we'll set the pace and show us how to do it. But I think maybe you'll practice a little bit more before we go, because it's a dangerous environment learning about it.
So
much
Sunny and Butch, thank you so much for joining us today. Hopefully you'll stick around for more of the show.
Yeah,
All right, congratulations,
Thank you, guys.
everybody out there.
Really
so
appreciate
much.
it. Thanks, guys. Good luck with your flight.
If you've just joined us, this is special live coverage of NASA's OSIRIS Rex asteroid sample return mission. You might be thinking, this doesn't look like a typical NASA facility. And it's not. In fact, it's because of the extraordinary capabilities that we find here, that we find ourselves in the Utah desert in the first place. We're coming to you live from Army's Dugway Proving Ground. We've got a video postcard to share that will give you a better sense of the glorious desert environment all around us. Take a look.
Okay, guys. Yes. Finally, the OSIRIS Rex is over here. Means the sample is over here. The Asteroid Bennu sample is over here, and we can see recovery team is now taking a look at the sample properly. And have they moved it? No. Okay. So yeah, I was saying that OSIRIS Rex has done its job. Everything seems to be looking good right now, and now it has gone. It is on its way to a new mission, which is OSIRIS-APEX. In this mission, it will try to study. So the thing which has come down is just the sample return capsule. The OSIRIS Rex spacecraft itself is, right now in space. So it has been redirected to a new mission, which is the OSIRIS-APEX, trying to study the another asteroid, which is kind of trouble for us. And now look at that live video.
I mean, you got to see a little bit from the NASA helicopter, but that was a close-up and personal look.
And look at this. We're in this place that almost looks like Mars.
So once it will reach there, it will study that asteroid and make sure everything is looking good over there. if required, not sure, but can happen also, because it has been proved with the NASA's DART mission that if it is going to hit the Earth, our OSIRIS Rex or OSIRIS-APEX spacecraft would already be there, and we can maneuver it directly to slam into this asteroid, so that somehow we can change its trajectory and not hit the Earth. So maybe it can save us one day. Not sure, but can happen.
By landing in the desert here, we can keep the Earth's ocean, all those absolutely wonderful waters out. This is the best place to bring home this kind of capsule. And look at her. She landed perfectly. Looks like a top sitting there.
So,
Absolutely gorgeous.
If we are, so they landed on this desert, but what about so if ISRO did something like this, where would they land it? That would be a question to see.
That's why NASA partnered with the Army's Dugway Proving Ground. Its vast open space makes it ideal for the task. But OSIRIS Rex is neither the first nor the last mission to land here. In 2004, the Genesis mission landed here at Dugway, delivering our first ever samples of solar wind. In 2006, NASA landed at Dugway again, this time with a mission called Stardust, which gathered samples of interstellar dust. Both of these missions helped fuel our understanding of the universe and wouldn't have been possible without a safe landing zone, just like OSIRIS Rex. After today, NASA and Dugway are looking towards the future to the Mars Sample Return mission that will once again be bringing a unique sample of our universe right here to Dugway Proving Ground. The U.S. Army and Air Force have been excellent hosts to us for months as we've been preparing for today's landing. That's one of many reasons I'm so pleased to welcome Colonel James Harwell, Army Commander here at Dugway Proving Ground.
Recovery
Colonel,
operations.
welcome.
Nominal SRC recovery operations have begun.
Getting an update.
Okay.
All right, nominal SRC recovery
Hi
operation.
Rifat, welcome to the stream. Rajasthan is a good location. I mean, maybe they can consider those Pokhran site, right? Maybe, not sure, but maybe. But that is already contaminated. Not sure, but yes, Rajasthan could be a good sample return site. But if we talk about like it will be like, how will the yes, they'll have to wow, this is difficult. Because the trajectory, they'll have to define it so that it does not come over Pakistan, but it should come via that, Arabian Sea. And it would be interesting to see which landing site they will select. So if it is Rajasthan, then that would be great.
We have a big collaboration at NASA with members from the Army and Navy, from the military services that have given us the opportunity to go to these great places in space ourselves as people. And can you tell us a little bit about the training?
Yes, sure.
People to be crew for flight into space?
Yeah, so if you look at it...
sea ocean is highly corrosive, and water can trickle down anywhere, right? So it's better to just land it over on a solid place. So it would be great for us to handle the contamination and all those things. So we'll see. We need to figure out. ISRO will figure out for sure for those orbital missions, and let's see where is the actual landing site going to happen. US is blessed with such open spaces and all. In India, I can't. Nope, there is no as such open space other than the Thar Desert of Rajasthan. So we'll have to wait and see.
Without wishing you a very happy birthday today. Happy birthday today.
Thank
is your
you.
birthday, and you
Yes, not whole Rajasthan is contaminated, obviously, but Pokhran site, maybe, not sure.
This is the rarest stuff we've ever had on Earth.
It is, and I mean, when we're talking about the origins of life, and that's one of the I have the coolest job in the world. A couple months ago, I was here, and out on the Utah Test and Training Range, we got to go out to an archaeological site and see 12,000-year-old footprints. And now we're going to get to see the material from the origins of
That
the
is
solar
also
system.
true, yes. So that, Gujarat and Rajasthan, what should I say? Area becomes kind of an ideal site, because if it lands in Gujarat also, then also it would be safe. So yeah, I think um, that would be their side, but we'll have to wait and see.
Pros at the top of their game, but future explorers are just now finding inspiration in today's events. Here at the Dugway Proving Ground, students attending public school can literally say that a sample of an asteroid landed in their backyard. We visited the school to hear their thoughts about the mission and how their teachers hope it might influence their dreams of future exploration.
My name is Deborah Rockmore, and I am the librarian here at Dugway Elementary through High School. I love that Dugway is part of this. We have a very strong feeling about Dugway.
True, I was thinking about that only. Like Pakistan, if somehow something goes wrong a little bit, only the trajectory can go over Pakistan, and Pakistan might take hold of all those samples and all. So yeah, I mean, we'll have to see where will they actually land this thing. Maybe in Gujarat, then Gujarat would be ideal candidate in that case. The Kutch is a good candidate, a large open area. So and not having a proper, boundary with the Pakistan would be a good thing. Let's see.
I was like, I live there. You hear about exciting things all over the world, and it's cool to hear about, but you kind of never think that you'll be, I guess, directly or indirectly involved with it. But to know that it's just happening here within eyesight is pretty cool. Let's go, OSIRIS Rex!
Go, OSIRIS Rex!
Let's go, OSIRIS Rex!
Let's go, OSIRIS Rex!
Let's go, OSIRIS Rex!
All right, let's go, Osiris Rex. I love that energy.
I do too.
All right, Jim, you're a planetary geologist. How did you get into this? I mean, these kids are just
Martian moon exploration. Phobos and Deimos. Nice. I did not hear about that mission. Would love to read about it, and obviously we'll stream it once that happens. But yeah, people have been interested in Mars, but not in Phobos and Deimos apparently. So what if we go and explore those things also? That would be great.
Unique from Bennu, but not unique in the kinds of materials we have here on Earth, thanks to other asteroid returns. These are the biggest.
Yeah, true. I think yes, you are right about this. Hayabusa 2 landed in Australia. So we can also. So it will be good to. It will be good, easier to land in other countries.
We are able to begin those recovery operations. You've been seeing on your screen in the bottom corner for the past couple minutes, team members beginning to head out and put flags of areas of interest where we'll want to sample for our sample curation team. And also just a note on our parachute deployment, the parachute was set to deploy based on capsule deceleration, and we actually reached that threshold earlier than predicted, and the parachute deployed appropriately. So everything was right there, working perfectly fine. We got that SRC, as you can see, successfully on the ground.
Okay.
It is perfectly resting on the desert terrain, and you see 3 of our team members around that capsule beginning to place flags to begin to collect samples. The team members here you see on screen are Scott Sanford, Dante Loretta, the principal investigator at the right of your screen there, and Francis McCubbin. These are key curation team members who will help us actually get a lot of these samples of the region there, environmental samples, collected and ready to be passed along to our team at the Johnson Space Center for curation efforts there. This is, again, a very key part of the mission. We want to make sure that there is no contamination of that sample return capsule from any possible atmospheric or environmental conditions out at that landing zone, that landing site. And so we're going to continue these operations and actually begin to scoop up some of the samples. And this will work like a well-oiled machine you'll see in a few moments. Dante, who was just on your screen a few moments ago, is wearing an armband, much like a football quarterback, if you will. He'll actually be kind of reading off the play calls as they go out and go step by step to actually scoop into the terrain about an inch down into the surface of the desert, scooping out a little bit of the rock and dust that's there, placing it into a bag, photographing the whole process along the way, making note of exactly where they collected that sample from. All this information will then be passed along to our sample curation team at the Johnson Space Center as they begin to actually open up that sample canister and see exactly what we got within.
China is, I remember China sample return also landed in the desert only. So deserts are a good way, a great place to land such missions, but we need to see. Maybe they'll land in Australia, not sure. We'll have to wait and see how the sample return would look like for India. It would be like great if we can land within India only. Okay.
We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology would continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS Rex samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born asking questions we can't even begin to imagine. So our team is just huddling off screen now, and our recovery operations will begin. You'll see a number of team members come out here. They'll be carrying with them a carrying fixture. It's a large metal fixture that has been perfectly designed to have our SRC resting within. They'll be bringing out a lot of thermal blanketing that will be used to protect our SRC during its flight back to the clean room here. Again, we want to make sure that that SRC is safe from any kind of possible contamination from the atmosphere. So they're going to do an excellent job of actually wrapping this SRC up and getting it prepared to transport to our portable clean room. That actual operation of getting that SRC bagged and stowed and ready to go on our long line operations for the helicopter will be a rather quick operation. As you see some team members from Lockheed Martin, their role is largely finished for today. They were operating a lot of the flight dynamics of that SRC, getting it to the ground, and now they can really just take a step back and relax, catch their breath after all the chaos of the morning. Very exciting moment for all of them, I'm sure, to actually see their creation sitting on the surface of the Utah Test and Training Range. Just massive, massive sigh of relief.
Okay, thank you so much. Yeah, so I was saying that I think that should be it for this stream. We'll have to wait and see how the actual things are there. But here you can see those flags are already put over there, which okay, he's explaining.
In front of the SRC, where the team believes the SRC is potentially dragged along the surface as it came to a rest on the Utah Test and Training Range desert surface. On the back side of that SRC are 4 additional pink flags, and those are our regions for control sampling. We'll actually go and sample all of these regions and compare back to areas we believe the SRC did not contact. You can see additionally, it's a little bit hard to make out with the bright color of the desert, but there are a couple white flags present at the SRC. And these are areas of operation for the team to actually be able to walk up to the SRC with the carrying fixture, place it next to the SRC, and actually begin to bag and stow our sample return capsule for transport to the Dugway clean room.
Yep. So yeah, that is what
already just an incredible
summarizes those flags over there. They'll sample those landing site also and give it a study. Live is getting over. Yes, I still don't want to give up hope on Vikram and Pragyan just as of yet, because I think there is a software issue which ISRO has done. Not sure. What my theory is that everything is fine for the Vikram, but it has not gave us a signal back to the Earth because the temperature, ideal temperature, has not reached. Waiting for that to be reached, right? If that is the case, then if the systems are functional but only the temperature is the issue, then we'll have to wait for the lander to achieve the ideal temperature with the help of the sun only. And obviously on the lander we have those heat insulators, right? MLF are there, so it would be very hard for the heat to go inside the lander, but hopefully it will slowly and steadily it will trickle down. So we'll have to wait and see whether if that is the case, because if that is the case, then hopefully they'll figure this out. If this lander wakes up and all, they'll figure this out, and hopefully they'll do a software update on that. But yeah, I mean, to be honest, yes. It's what should I say? No hope zone right now, because Vikram or lander should have communicated back already. But yeah. Yes, we have to wait, but yes, you are right. I mean, it's been a while. Should have you know, reached those temperature, but let's see, let's wait. I am just waiting for 14 days to get over. That's it. Once that is over and still we did not get anything, then it's dead for me. No matter what ISRO says, but it's dead for me. So yeah. Okay, Daniel, I'm also ending this stream, so yeah, we'll see you guys soon. For that, thank you so much for tuning in, though. And what we have Psyche mission launching, so that is also one more thing, guys. So this has returned back from Asteroid Bennu. There is one more Psyche mission which is going to launch in October itself, which is amazing. 5 October, that to a Falcon Heavy launch. That is amazing. The Psyche mission is a very is going to a metal asteroid, to be honest, and it will be amazing to see how that will pan out. But yeah, so hopefully I'll be streaming that too. So yeah, things are looking great, and I think I should end this stream now. It's been a while, and thank you so much for tuning in. And yes, OSIRIS Rex capsule is on the ground. We have the capsule over here on the Earth. Now JAXA and NASA will exchange their samples of the Hayabusa.
SRC is bagged and secured in the handling fixture.
Okay. So yes, Hayabusa's sample of the U2 asteroid and Bennu's sample will be exchanged and studied and contrasted, and similarities and differences will be taken into account, which will give us more science points, right? Which is always a great thing to have. So yeah, and the spacecraft itself has headed towards another asteroid, which it will reach in 2029. So yeah, thank you so much for tuning in. We will meet again for another launch, which should happen, which is the one, okay, 5th October only. So there is a launch on 5th October. Two launches basically, Vega launch and the Falcon Heavy will meet in the live stream on that day only. So thank you so much for tuning in. Have a great day. Until then, this is Priyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.